I'd like to thank all of you for joining us this morning. My name is Colin Gibbs. I'm the editor of Fierce Wireless. For those of you who are active on Twitter, please feel free to use our official hashtag, which is hashtag FierceCTIA16, and our handle at Fierce Wireless. I'd also like to thank our sponsors. Ingenu or Ingenu?
Ingenu.
Ingenu.
It should be Ingenu, but we knew no one in America would pronounce it right.
Sequans and Qualcomm. For more information about our speakers, please check the programs on your table. Also, please fill out the information forms on your table. I'm told they're brightly colored.
They can't hear.
Me, that's me. Okay, I will talk a little more loudly, and yeah, thanks for letting me know. If you guys can't hear, please continue to let me know. Please fill out the feedback forms on your table. We're also holding events at CES and Mobile World Congress, so keep an eye out for those, please. We have a 5G event tomorrow morning, another breakfast hosted by my colleague Mike Dano. If you want to hear about 5G from executives from Verizon, AT&T, and other top players, please register for our breakfast. I've been asked to pass on. You could register for that today, make everybody's lives a little bit easier tomorrow morning. And also asked to pass on that that's not included in the typical registration for CTIA. So we'll plan to leave about 20 minutes at the end of our discussion for questions from the audience, and we'll make sure to leave plenty of time for you to get to this morning's keynote speakers at the show. With that, I'd like to ask everybody to please turn off their cell phones and other electronic devices, and let's jump into this. Thanks to all of you guys for participating, and to you, Lani, thank you. Very excited about this. We've got a lot of different perspectives up here, a lot of knowledge. And so with that, I'd like to ask our speakers to introduce themselves, briefly explain what their roles are in relation to the IoT. And perhaps if you back a particular technology, very briefly, we can discuss that a little bit if you want to tell us just a little bit about the technology you and your company are backing. But again, I'd like to keep this brief. We have 6 of you. We have a lot of ground to cover. So with that, Lani.
Okay. Well, thanks for joining. 7 a.m. on day 1 of a conference. I'm highly impressed that I'm not speaking to an empty room, especially in Las Vegas. My name is Lani Ingram, and I'm the Vice President of our Smart Communities and Venues organization within Verizon. And our role really is my role especially is to be able to focus on how we can enable our technologies to drive improvements within communities around the world. And this could include cities and municipalities, universities, sports and entertainment facilities. And in addition to that, I'm also responsible for our ThinkSpace platform, which enables the rest of the IoT solutions, as well as things such as our telematics solutions and our small, medium business consumer arm. So we are really looking at a tremendous amount of different types of technologies, especially leveraging our 4G LTE network to be the basis for most of this. But we recently have also announced our Cat-M and Cat-1 device, and I think that is going to actually be something that we will talk about while we're here, but we see that as being a real strong enabler. And also looking at future technologies, especially being very aggressive with 5G, et cetera, to really look at the diversity that's needed to drive this industry. So thank you.
Thank you. Cameron.
Hi, I'm Cameron Coursey. I'm with AT&T's Internet of Things Solutions Group, and I lead the product development organization. I guess that means that we put the Internet in things for AT&T, and we kind of make it work from the technology to the launch of the technology with our different customers. So we've been in this for a while now, supporting it through different technologies. We're really multi-network. We believe that the IoT space can be one where a lot of different technologies can be used on the wireless side. There's billions of possible connections out there. So we embrace the ones that we already have a lot going on in all the cellular domains. We've done that for a while now. And moving into the licensed low power wide area world, which we'll talk about today, and satellite and other areas, Wi-Fi. So we embrace a lot of them.
Thank you. John.
John Horn, I'm the CEO of Ingenu, and we are the only technology that's been built from the ground up specifically for machines that didn't take a stop along the way doing anything else. And our technology is called RPMA. And if you look at the machines that are deployed in the world today, 86% of the machines already deployed could run on an RPMA network. We have networks running on 5 continents as we speak. We have 63 countries in process where we are going to be building networks either ourselves or through licensees. So we will have a significant large global footprint where you'll be able to use one radio, one device, anywhere in the world. And it's a phenomenal technology that can support the IoT ecosystem.
Thank you.
Good morning. My name is Craig Miller. I'm the Vice President of Marketing for Sequans Communications. We're an LTE chip maker, and what's sort of unique about us is we're pretty uniquely focused on optimizing LTE chips for the Internet of Things. We were the first chip company to launch and commercialize LTE Category 1 for IoT applications. We were first to launch Category M1 back at Mobile World Congress, and we're demonstrating it live this week in our space here at CTIA. And I think we view our role as sort of reducing the barriers for device makers and M2M implementers, barriers in cost, size, power, simplicity that maybe have existed in the past or are perceived to exist in the industry today. And so we're doing everything we can to pull those barriers down and make it easier for developers and implementers to make great IoT applications that run on LTE networks from folks like Verizon and AT&T.
Thank you. Arthur.
My name's Art Miller. I'm part of our IoT business unit within Qualcomm, specifically on the chipset side. I handle our smart cities and industrial Internet of Things space. We are also focused in LTE. We also have some technology that's been focused on machine-to-machine over time. We have made a few stops, done pretty well in the smartphone space. But we are focused on M2M. We've been heavy drivers in standards for 3G, 4G, and continue to drive 5G. We believe the evolution path is going to be necessary to truly connect all of these things worldwide with standards-based solutions. We're very excited about M1. We're partnering with a few folks on the stage to drive M1 products into their networks. We're very proud of that, and you know, we're very excited about IoT. We think there's a lot of possibility. One thing that we also have is we're uniquely positioned where we have connectivity across the board: Bluetooth, Wi-Fi, PLC, anything that needs to be connected, we can connect. And so we have a tendency to look at things more from a system approach of all things at the edge. Also, we believe that as edge compute becomes a bigger deal, we're uniquely positioned for that based on all the things we've done in smartphones.
I'm Michael Orr. I am with Sigfox. I am the Vice President of Sales and Partners for Sigfox in North America. We are a global, low-power, wide-area network provider. We're building a network globally. We have operations in 24 countries with a target of 60 countries by the end of next year. We, too, were designed from the ground up to be a strictly IoT network, very small amounts of data, very low power, very low cost. That's our niche. We are about enabling the masses for IoT. All those devices that have not had an economical or power-efficient way to get on the internet, that's what we enable. That's why we're here.
Thank you all very much. When we first started talking to this panel about questions, when the speakers were talking to me, Craig suggested we just jump right into the title of this roundtable, which next generation networks are going to live and which are going to die. And as compelling as I found that, and I like that a lot, we're going to lay the foundation first before we jump right in there. So with that in mind, Art, I'd like to ask you, where do you think we are in the evolution of networks for IoT use? What kinds of networks and technologies are being used to serve the IoT right now, from your perspective?
Okay, well, I think IoT exists today. For people to say IoT doesn't exist, I think there's a bit of a misnomer. It's been there for a while. It's previously called machine-to-machine. IoT is, I guess, a sexier name at this point, and people are excited about it. That's why we all have it on our business card now. So it exists. The problem is there were some barriers to entry, which some of these folks have already talked about. But as things progress, I think just recently with 3GPP focusing on their narrowband solutions, specifically M1 and NB1, there's now the perception of barriers being gone, opportunity for devices to be more cost optimized and longer life in the field. And then moving into 5G, we certainly see the narrowband technologies that have been introduced as 3GPP this year and being commercialized early next year on the carriers are kind of this foundational base for 5G. So things will continue to evolve in parallel. It'll act as a foundational base for 5G. So we think we and 3GPP based technologies are uniquely positioned for longevity. But we're at the beginning. We're certainly, the sky's the limit right now. But there's a good future ahead.
Very good. Anybody have anything to add to that? Okay, very good. Do the networks and technologies that are being put to use right now, do they vary based on different vertical markets and use cases? And if so, how? Michael, you want to tackle that first?
Oh, well, certainly the networks do vary a bit based on use case and application. I mean, you may want a small cell to cover a specific area in a factory or something like that. So you can have the use case drive the deployment of the technology that's out there today. But by and large, Sigfox's network will be homogeneous. We're not going to change the network for the different applications. We may need to tune it up here and there as we go. We need to tweak it a little bit. But by and large, it'll be the same network everywhere we deploy.
You know, if you look at what's happened in the technologies out there, the carriers have done an extraordinary job with LTE. LTE has delivered on all the promises that we all expected it to when I was sitting in these chairs, and done an extraordinary job. But you know, LTE is built primarily as a human interface technology, and it's been extraordinary. And now we're, you know, with the discussions coming with whether it's Cat 1, Cat 0, Cat M, LTE, whatever, NB-IoT, whatever it's going to settle on in the end, these are ways to try to maximize LTE more for the machine network, instead of having a network for machines. And that's what RPMA is built for. It's interesting because on my board I have the former CEO of Verizon, the former CTO of Verizon, and the co-founder of Qualcomm, who all say that LTE is the absolutely everything we want for people, but RPMA is for machines. So I think technology is going to come out here with the expansion of what Sigfox is doing, what Ingenu is doing, and others, and it will fragment to a degree based upon the needs. We can't do high-speed data or video or voice. These guys can live that all day long, but we can provide a technology that gives you an extraordinary opportunity to really have coverage everywhere you need it and have the machines prioritized, not the people, but the machines, so you have the coverage every day, everywhere you need it.
So maybe if I can just add to that, sorry, just real quick. I think that use cases for IoT in general are incredibly diverse. And as a result of that, it's going to take a diversity of different types of technologies to really solve the problem. I don't really believe that there will be one network or one technology solution that is going to be the basis for every type of use case that are out there. I would say 90% of the use cases we haven't even thought of yet on the planet, if not more. You know, give an example of, say, something in my industry around smart communities, something as simple as parking. If you think about maybe a parking sensor that might sit in the cement itself, or something that might be on the sidewalk, maybe that would require one type of networking device to be able to do that. It may also be able to have a parking solution by the cameras that are going to be sitting on top of light poles, and the video feeds that can actually detect whether or not a parking spot is there or not. And honestly, I believe in the end it's probably going to be a triangulation of several different types of ones, because no one is going to be able to provide 100% of the right type of accuracy in that data to provide the level of solutions that we're going to expect to see in the future. So I do agree with everything you're saying, but I just think it's going to be a combination of so many different technologies, the ones that we're talking about today and ones that will continue to develop in the future.
I would just add, Colin, I think from our perspective, the beauty of LTE-based technologies is these networks exist. They've spent billions on spectrum and coverage to build these networks that cover most of the United States already. You don't have to wait for a new network technology to be deployed. And within the LTE framework, you've got a range of technology options, from the high-speed stuff for the media and video that you're talking about to the very, very low data, payloads of a parking meter sensor. That can all be served on the same RAN using LTE-based technology, going from Cat 6, Cat 4, Cat 1, M1, narrowband, all based on LTE technology. That's the beauty of the 3GPP standard.
And if all those worked so well, you wouldn't have NB-IoT, Cat 1, Cat 0, Cat M, and all the other things, because LTE would be the answer. LTE is the answer for some things, but the vast majority of machines don't need LTE, and it doesn't give them what they need.
But those are all LTE-based
Those
technologies.
are all LTE
I
technology.
realize that, but
Yeah.
they're based upon an LTE backbone, and you've got all these different modules, all these different radios.
Yep.
You're complicating thing that's already too complicated when it needs to be simplified.
So I take some exception to what John's saying. I guess
Why am I not surprised?
Imagine that.
You know, we're not after the internet of a few things. A few things is what RPMA can do, right? We're after the internet of all things. And to do that, that does take multiple technologies. That takes things that can go very, very fast. Big bandwidth, right? To do firmware updates to things, or set up Wi-Fi hotspots in connected cars. It takes very, very low bandwidth things that can remotely start cars weeks after somebody has left them somewhere, right? With very good extended coverage, with very good power saving mode. All of these are things actually that the cellular technologies can do going forward with the licensed low power wide area LTE-M and narrowband IoT.
Michael, anything you want to add to that?
Well, certainly. I certainly see that, to Lani's point earlier, IoT is really, really big. It's bigger than anything we've ever done before. Everything we've done so far has been enabling people with devices. Well, we succeeded. I think all of us have been in the mobility space. We won, right? Everybody's got a device already. 7 billion people on the planet, 8 billion subscriptions, everybody's got one. How many machines are there in the world? I don't know. Do you know? There'll be hundreds of billions. I think going forward, every device that's made over the next 5 to 10 years will have connectivity in it. Every single one. Silicon's cheap, cloud is cheap. Why not just stick it in, right? It's going to be there. So once it's there, then what do you do with it? Nobody knows how long this is going to take. Nobody how long it's going to take to get that big curve to go up. But I do know that no one technology sitting here is going to fit all those things. It's not going to happen. Is there room for all of us? Yeah, I think there's probably room for all of us for a while. Are some of them going to fall by the wayside? Yeah, probably yes. They always do. But it's a really, really big market. Way bigger than anything we've seen before, right? So there's going to be room for LTE. Some people need video. Some people need real-time stuff. We're targeting the very low end of the market, right? Low cost, low data rate, very low. Is there room for that? Yep, there is, absolutely, right? So it's a really big market, and it's a mistake to think that any one of them is going to take 90%. It's not going to work like that. That's how I see it.
You're obviously right that there are a lot of technologies. Am I still on here? Can you guys hear me?
Yeah.
Okay. There are a lot of technologies already being deployed, many more being developed. And the title of the panel again is which will live and which will die. Are we seeing any signs of attrition in any of these technologies? Are we seeing any of them fall by the wayside?
I don't see it yet. It's too early, right? I mean, we're just starting the big IoT deployment, right? It's just starting to happen. It's too early for things to fall by the wayside, unless somebody made some kind of catastrophic mistake. I mean, there are some low power WAN technologies that have been proposed and have fallen by the wayside already, but not anything mass market. I think it's too early for that to have happened yet.
Very good. Thank you. Craig, back to you. Where are we in the evolution of LTE-M and NB-IoT commercial deployments?
Yeah, so I think what we've seen is, and this has been actually fairly remarkable for 3GPP technology. If you followed it over the years, they're not exactly known for their pace. But I think what's been clear, and we can thank guys like John and the friends at Sigfox for actually kind of lighting a fire under 3GPP and the operators that support it to move fast on IoT-specific standards that leverage the strengths of LTE technology and the deployed networks. What you're seeing now, and Release 13 specifically is what I'm referring to, which locked down earlier this year, two new narrowband technologies were defined in that standard, Category M1 and Category NB1, or what's narrowband IoT. Two different levels of performance, two different use case kind of profiles, both of them defined in Release 13. What you see now is, I think, and we're an example of this, Cat M1 silicon up and running now, working with network vendors and operators to start getting ready for trials and deployments by the end of the year. Narrowband IoT is close behind, I think, and in different parts of the world, different operators have different priorities. They may prioritize narrowband over M1. Eventually, they're all going to deploy both because they're both needed. And that's how we see it. I think you'll see the first commercial networks on M1 around the end of the year. I think both of our mobile operators on the panel here have made some recent announcements with regard to that. And narrowband IoT will be shortly thereafter.
Anyone else? Thank you. We've already touched on this a bit, but to drill down, what should we expect to see as dedicated IoT networks gain traction alongside traditional wireless technologies and networks? Will the two segments complement each other, or will they compete with each other? And part of that question includes like the business model. What kind of partnerships are we going to see? And are there different business models between the two, between those two types of businesses?
The answer to all the above is yes. Frenemies, compete, get along. I mean, we have licensees around the world that are going to be competing against the incumbents. We have licensees around the world that are the incumbents that are going to be building RPMA networks within their footprint. So I see there's so many different ways to compete and to cooperate. There's no way we're going to connect 1 trillion machines with one technology. I mean, we're already here listening to 3, LTE, M1, NB-IoT. So there's 3 just on the cellular side, right? And that doesn't even count the sunsetting of networks and all the other issues that come with it. But the bottom line is that there's room, as everybody has said, for all of us to be successful if we create the right environment, the right business model, and have the technology to back it up.
I would agree with that completely. And one of the things I feel as well is, it's actually one of my favorite things about being a part of this particular industry is, even though we're all competing in many ways, we really are partnering because we want to see this industry successful. The pie is big enough for everybody, and we have no idea how big that pie is even going to grow if we're all successful. And I think the industry is looking to us as leaders to ensure that we are working together. We need to ensure that we are building the same standards and that we are operating with similar thought patterns and architectures and driving business models that are not confusing to the market, to your point on that. I think that it really requires us, to challenge one another, which we do all the time, but also to work together. It's my favorite part about this industry, actually.
Thank you. Spectrum, I'm just going to throw this out there because I would imagine you could all speak to this. But what role is Spectrum playing as the IoT begins to get legs, and what role will Spectrum play on either side of this, the cellular networks and the dedicated IoT networks, as these things evolve over the next few years? Anyone?
I think it plays a big role. I mean, you need Spectrum to do anything wirelessly, right? So you have to determine then, is it licensed spectrum, is it unlicensed spectrum, right? Today, IoT is in both, and it will probably stay in both, right? There are use cases where you need to use licensed spectrum for certain things, and you have it around the world, and you're able to do roaming globally with standards like the 3GPP standards. There are unlicensed ones that probably take a little bit more to make sure that it works everywhere in the world, right? But I think they're all going to exist, and the spectrum that we have to work with, we obviously need to make sure that everybody is using it for the right purposes and making use of it in an efficient manner. So yeah.
So in our case, for Sigfox, where we're targeting the lowest cost, lowest power consumption for low data rate applications, it's very important for us to be in unlicensed spectrum because we're trying to get the cost as low as possible. But that does come with a burden too. I mean, that spectrum is wide open, but everybody's in there, so it's noisy. We have to be able to work in that kind of environment. We don't have as much control over it. Whereas in the licensed spectrum, you have more control over it. It's not as noisy, et cetera. So our trade-offs for both. But we're targeting the lowest cost applications. We need to be in the unlicensed band. It's important.
And I think that's key. You mentioned it's going to be how much control do you need. many use cases that require quality of service or certain secure elements or control of the devices. I think that's going to fall clearly into the licensed spectrum.
I disagree. I mean, we've got networks running all over the world. I've got networks running nuclear power plants. If they aren't secure, we have a big problem. And so you can be an unlicensed spectrum, and if you manage it properly, and you're a good neighbor, and you can do very well in that spectrum. We have networks running in Los Angeles, Seoul, Tokyo, sort of like congested environments. And they're running very, very well. And the advantage that we have, because we picked 2.4, is one radio will work in every country on the planet, because it's the only spectrum that's ubiquitous in every country on the planet. And we're about, again, making it easier and simplifying this process. And for anybody that needs a true global solution, whether it's shipping or whatever it happens to be, one radio is a pretty appealing opportunity for them.
Hey, where is that nuclear plant at?
Yeah, I don't want to be.
Because I want to stay away from there. I'm just,
Thanks, Cameron. I appreciate that. It's in your backyard.
yeah.
One thing that I would say will be interesting over the next, say, 5 years, if the market's going to get as big as we all hope and expect it will, is the existing allocation of spectrum, especially in the licensed spectrum, is it adequate? Is there enough of it? Do we need to go to 600 megahertz, which is under auction right now in the U.S., which gives the properties, the propagation and coverage and properties of the low band spectrum is really good for a lot of IoT applications, getting wide coverage, indoor penetration, underground, those kinds of use cases. I think it'll be interesting to see what the operators in particular decide where they're going to focus the IoT applications, which bands.
I think it's really important for us to also just keep in mind what problem we're trying to solve. And each one of those are going to require a different level of security and protection amongst that. If you're, again, working with a community, which is my world, and you're talking to a government leader, and they're not going to want to do something smart, and then all of a sudden, something goes haywire with some of their primary assets within the city, and people get hurt or their data is compromised. So I think in areas like that, we probably spend a lot more time on focusing on the security of the data, security of the information, ensuring that things are operating at a level of efficiency that we're used to doing every single day, and that takes a lot. That might be different maybe in other technologies or other use cases that may not necessarily require that level of security and protection. So again, I do think that there will be different technologies to support different areas, but any place that does require a certain level of protection and security, I think we need to ensure that we've got the right technologies to support that.
Thank you. Let's talk about costs for a few minutes. What are traditional 3GPP mobile operators doing to reduce the data plan costs to enable new IoT business cases to succeed? And how does pricing compare to those offered by non-3GPP LPWA networks? I'm guessing a couple of you have opinions on this. Craig, let's start with you.
Well, I'm not an operator, so I'm not going to put pricing, data plan pricing numbers out there. But I do know that we talk to the operators around the world, and there is great awareness of the need for a different approach to these use cases than the traditional, mobile phone plans and tablet plans that, that exist out there. So there's great awareness of it. There is active work underway at a lot of operators to optimize the actual OpEx, if you will, of running IoT services on their network compared to a mobile phone. So there are things you can do in how you administer the network, the back office, the core network, what you use and how much it costs to operate that network. So that enables them to stay profitable while reducing, the cost of data plans. So I think that's an important, there's a lot of focus on the cost of modules and hardware. Guys, that's going to get taken care of, right? Cost follows volume, and complexity reduces cost, and all of that's happening in all of our technologies. So the cost of the module, the chip, et cetera, Moore's law and physics are going to drive that where it needs to go. The cost of the data plans is up to the operators, but I know that they're working on it. I think you should ask Cameron and Lani.
The thing that if you work in the IoT space in the enterprise world, you would probably understand is that the majority of the data plans that we're talking about are not the same as what you as a customer would use for your smartphone or your tablet. These are bulk data plans that get sold to enterprise customers at very, very low rates that we don't talk about. This is so there's not as much of a barrier, I think, as people might think there is right now to that from the air interface charge perspective.
I have to really agree with that. I think when people think immediately of wireless, they think of their own personal phone. And there's a tremendous amount of benefits to working with carriers such as AT&T and Verizon and others to work out a plan that's right for the enterprise and for cities and public areas. And we really do spend a tremendous amount of time ensuring that we find the right business model for the right solution. So I kind of keep going back to the use cases over and over again, but it really does drive things. We can't really call the Internet of Things one bucket. It's so diverse and it's so varied that it's going to require different business models, different technologies, different combinations of it in order for it to be successful. And I think the reason that we really do focus on affordable data plans for that is we want to be able to see this industry thrive and grow. It's to the benefit of not only everyone up here on stage, but to the planet in general. And in order to make that happen, we have to enable it, and we get that.
I was a cellular guy for over a decade and a half and saw massive changes in what we were able to do pricing-wise, and cellular's definitely become considerably more competitive, and that's why the whole IoT ecosystem is growing so rapidly, because the pricing has come down so low. But there's going to be times when it just doesn't make sense. There isn't the human backbone to support the machine backbone, right? And just a specific use case, before we started building public networks, Shell Oil built an RPMA network in the Niger River Delta. They kept trying to get the cell guys to do it for years. It just didn't pencil out. There weren't enough people, but they had a lot of assets there. So they spent $87,000 to build a network. Here's Shell Oil. They don't know crap about wireless. I hope there's nobody from Shell here. But I mean, the bottom line is they're an oil and gas company, right? And they spent $87,000. It took them 90 days to build the network, and they saved $1 million the first year. Pretty good ROI. So these alternative technologies that some of us have an incredible opportunity to do things where it just doesn't make sense on the cellular side to do it.
Yeah, I think John brings up a really good point. It should be driven by ROI in most cases, right? Sometimes it's not, but it should be, right? And in some cases, the licensed spectrum, a little more expensive, however that may play out, makes the right sense. In some cases, what we're doing makes the right sense, but these all should be ROI-driven cases that are put out there.
And in fact, this is often where all the technologies come together and they meet. There may be, an area that is covered by one unlicensed technology, but there's no backhaul anywhere to get the data back somewhere else except for a cellular link. Or, my gosh, if it's in the middle of nowhere, it could be a satellite link. All of these are IoT applications and services that can be delivered.
We've talked a lot about networks and technologies. Are there other differences between dedicated IoT network providers and cellular service providers beyond the actual networks and technologies? Are there other things that somebody looking to deploy IoT services should be considering when looking at all these things? Anyone?
I'll just start with that one. I think one of the areas that I hear about over and over again is that there's the concept of being able to throw out a technology, a particular area, and then someone else might throw out an architecture. But it's very different to be able to actually work with a partner or work with a customer, whether it's an enterprise customer or, again, in my area, a city, from beginning till end. And one of the things that I really enjoy about the area that I'm in, and I think AT&T and others are probably in that same boat, is we're really with them all the way through. And I think that's an important part of the IoT technologies. You can't just sell it and leave. It's not just an independent technology, because we're still learning. I always call it we're building the airplane while we're flying. In many ways, that's where the industry is. And so you kind of have to stick with that customer all the way through that cycle, through implementation, through operations, work with them, modify, adjust. It's not something we talk about a lot because we get so focused on the technology, but there's a very real implementation operations component to IoT that we're learning as we're going. And I think that's one of the fun things that I think about in our area is being able to really make that journey with our customers.
Yeah, I think they also need to consider, the reliability, the security, the coverage, footprint, right, that they need for the application, the performance that they need, right, based upon, what needs to be transmitted back and forth. All of these things come into play, the economies of scale, when you're making a decision on, which one of these to use.
I think reliability and security and all these things are critical. Stability long term. Is that technology going to be there? Is the coverage that's there available to you, or is there no availability to you because it's congested with other things? I mean, these are all the critical factors that people need to look at when they look at the entire picture, because all people want, they want the data. They want to make sure they get it when they need it, and it's there and available to them. So those are going to be key factors as people are looking at that. If they have to go replace devices down the road, it destroys the ROI because there's another technology coming along. Those things all have to be part of the equation as they look at the entire long-term picture of what it is they're trying to deploy.
At the same time, they need to look at, do they have an evolution path? As Lani mentioned earlier, we don't know what the use cases. We're taking use cases that we know today and putting technology in place. But as people figure out new use cases, we need to be able to be flexible, scale, have an evolution path. It does no good to deploy something for a specific use case and then find out later I need to do a truck roll to replace it for a different use case, independent of technology going away or staying. Those are the things that I think some of the things are the most important, is to remain flexible, have an evolution path as we move forward in IoT.
Yeah, and I would add to that in the same vein that I think all of us have to be very nimble going forward to make changes very quickly to go forward. And I think that may position companies like Sigfox, Ingenu, in a better light. And AT&T and Verizon sometimes don't move that fast. No offense, but
Really?
Really, we're in a position to move a little faster, and maybe that's important. To be nimble, to get out there, to satisfy those new use cases right away.
The greatest number of truck rolls I've seen are because of sunsetting Gs. So, those get a little painful.
This is one of John's favorite things to bring up. So,
I knew I'd get Cameron on that.
let's talk about it. I wonder, John, how old is your company? How many years have you been around?
8 years.
8 years. All right.
Okay.
It means something to have a company that's been around for a long time, that is going to be there a long time from now. That's just something that people need to consider as well. Is the company going to be around? Is their technology going to be around? And gosh, if I knew what's going to happen 5 years from now in terms of IoT technology, I could make a lot of money. Nobody knows, so to say that we've got a technology that's got to be there for 20 years, that's great to say. How practical is that when it comes 20 years from now, when all the people that installed that are long gone in Florida or wherever, retired, and the technology has moved to an entirely different place, which would blow away anything that's in the ground now? What would the economics be 20 years from now? I just say I think that people need to think about that, when they make these choices about technologies and sunsetting of technologies as well.
I like your new talking points. They're pretty good. But, if you have 2G, you're guaranteed to die. So, you talk about the longevity and so forth, but the reality is you guys need to refarm the spectrum. You're not doing it to be bad or anything else. It's to maximize that spectrum for 4G, 5G, and 6G when it comes. It's not, it's not because of anything other than maximizing your greatest asset on that side, which is your licensed spectrum. It's not a bad thing, but if the reality is when people have to roll a truck, that's expensive. And we're telling them they're not going to have to roll that truck. And you can joke about we've been around for 8 years, but Google hasn't been around very long either. And I think people would argue the fact that they're doing pretty good in their segment, and we'll do pretty well in ours.
Not to put too fine a point on this, this is related, but not exactly the same thing. Lani talked a little bit about carriers maybe having an edge by not just selling, but basically customer service, I think is what you were saying, right? Like being there with the customer through deployments and beyond. Is that a concern? John, Michael, either one of you guys want to respond to that at all?
Carriers have an absolute brand advantage. They've been there a long time. They have massive organizations, and they're going to do very, very well with a segment of the marketplace. There's no doubt in my mind, and I believe NB-IoT will be the winner. I don't think it'll be Cat-M, Cat-0, Cat anything else. I think NB-IoT in the end is going to have a major market share, but it's not going to capture the majority of the market share or all of the market share. There are so many other things that are going to come out there, and we have the ability to support those customers. We're supporting customers all over the world right now, and we can support them very, very well. But yeah, they have that inherent advantage of relationships and brand and organization that's been there.
Yeah, I would answer the question almost exactly the same way. I mean, certainly AT&T, Verizon, they're ubiquitous. Everybody knows the brand. They have huge organizations. You have huge customer support capabilities. But we're growing rapidly. We support customers around the world. And as we grow, we'll be able to do it just as well as anybody else will be able to do it. Just it's going to take a little bit more time for us to grow. I would argue we're more nimble. We can tailor ourselves to specific customer needs at that point in time very rapidly. And that's an advantage for us.
I just wanted to bring up a point as well, because I think there are a couple of interesting misconceptions that are out there with large companies such as ourselves. You know, one, again, we talked about, wireless equals expensive, and that's certainly not the case when you really dive into it. The other one is, gosh, large companies can't move as fast. And I have to say, I'm actually very new to Verizon, so this is a personal experience, but I've only been here 6 months, and the amount that we've been able to accomplish in 6 months has blown me away. I think that our large companies does not necessarily equal the fact that we are slow. It's actually quite the opposite. And I think it's because of the stage that we are in IoT right now, and I think you were mentioning it before, that it's really about to really take off and scale. And when it gets to that point, the reason I came to Verizon is I loved the tagline, and one of the reasons is, we deliver the promise of the digital world. And it takes that scale, it takes that breadth, it takes the security, it takes all the assets from end to end to come together to then really be able to make something come to fruition. I just wanted to talk about that, because I think that there are myths out there that, sometimes people would naturally feel, but in reality, I've been blown away.
Let's talk about standards for a minute. What role will the development of standards play in the evolution of the IoT? And this may seem elementary and maybe even obvious, but what are the advantages and disadvantages of standardized network technologies? Anyone want to start with that one?
I think I already commented a little bit about the release 13 and 3GPP, how that went miles, order of magnitude improvement in serving a lot of new IoT use cases using that LTE-based technology. There are a lot of hidden things inside the standard that don't get talked about as much. We dwell on Cat 1, Cat-M, narrowband IoT. Those are just capabilities of the network performance, right? There's a whole other set of features built into the standard, power savings, mode, extended DRX cycles that allow these devices to go to sleep for long, long periods of time and still remain on the network effectively, so they can wake up, get their transmission over, go back to sleep, live on a battery for 10 or 20 years. Those are really important pieces of the standard, and those kinds of innovations are coming furthermore in release 14 and release 15, and as we head towards the 5G specifications that'll come out of future releases, you're going to see optimizations in the technologies, not just the air interface or the speed of the network, but in the overall end-to-end attributes of the connectivity, and those will be defined in a standard. And I know Qualcomm, big supporter of standards. We're big believers in standards. I worked at Intel for almost 20 years in the PC space. Standards were everything. Make the interfaces standard so we can all build and innovate and cost reduce and scale. But those standards are crucial to the success of the industry.
Yeah, a couple of things. I think that you're able to get the best minds in the industry working together in a standards environment. You've got the chipset guys, you got the infrastructure guys, you have the wireless carriers all working together to make the best technology that they can standardized, right? And then you get the advantages of interoperability across the globe of these capabilities. That it's not just one-dimensional in that respect. So those are all very valuable aspects of standards. One could argue that they've in the past taken a long time to get from paper to implementation. As was mentioned earlier, that has dramatically decreased. I think it'll continue to decrease as the technologies are continuing to improve in order to get things out to the field faster. And we're seeing that with LTE-M.
Yeah, and I think getting those minds together in a room to solve problems as they evolve are going to be a big thing. One of the things in 5G, they're trying to figure out how can a common core network handle the legacy 4G so we don't have to shut things down, and the new use cases for 5G, and not just 5G, but multiple air interfaces. How do you have a single core handle a Wi-Fi network and a 15.4 network, and in addition to 4G and 5G? Those are the type of things that get solved in standards and allow you to launch something that you know will work when you go from one country to the next. That's not necessarily the case when you start switching technologies.
I think that if you think about when the internet was originally created, the internet protocol, it really was a bunch of really smart technologists who came together and said, you know what, we're going to use a dot instead of a comma. We're going to use www instead of something else. And it wasn't actually incredibly formalized. It was, people coming together and agreeing that in order for us to truly drive something at the scale of the internet, we needed to come up with a few things that we're all going to agree to. I think the Internet of Things is that, X. And we do see a lot of the same spirit in the standards bodies and in forums such as this, where we do realize that we all need to figure out how to work together, we all need to come up with certain things, and we need to standardize on a dot versus a comma, or whatever it might end up being. And I do see that spirit throughout forums, such as this, conversations such as this, and definitely different protocols that are being set up within each individual vertical within IoT as well. Because you've got kind of like the broad base, but then you've got specializations that you also have to kind of care for.
If you look within 3GPP, there's a lot of standards, right? So, there's room for more than one standard in the world. You guys are living proof, right? You got a lot of different things happening. And the key is to make it as simple and ubiquitous as possible. And I think the cellular guys are getting there closer with what's going to be NB-IoT. But we believe having, one radio everywhere is really important. It's even more important than one standard, because the radio creates a standard. And so there's benefits to win either way. But I don't think there's going to be one standard. The cellular is going to have multiple standards as they move through the evolution, and that's okay.
Any final thoughts on that? Very good. I've got a few left, but we have a little more than 20 minutes. So I'd like to throw it open to the questions from the audience. If anyone has any, we've got at least one microphone roaming around here. So if anybody has any questions, in the black, in the back. You're wearing like blue, I think.
I was going to say, thank you.
I'm going to jack my voice up. A little bit of talk about spectrum and standards. I can remember I was on a plane next to a guy, and he says, what do you do? I said, I'm in the security space. He said, I said, what about you? And he told me, I can't remember, it doesn't matter. But then he said to me, hey, I just bought a house. And I said, oh, glad someone in America is. He goes, oh yeah, I got it fully wired. It's a smart home. I got infrared, right? I got motion sensors and video in every room. And I looked at him and I said, you don't have to take my word for it. And you certainly don't have to watch Mr. Robot to maybe draw your own conclusion. But you might want to put a piece of tape over the video camera in your bedroom. Because you're going to be a hero for either good reasons or bad reasons at some point on the internet, okay? So I've heard no discussion of security whatsoever. We see a lot of folks rushing to get their connected device to market, and security is either, well, frankly, in most cases, it's not included. It's tricky because it's a small platform. So do you have some thoughts on standards or approaches to security, especially for these connected devices? And by the way, let's just go with an easy one. The US Army has decided to deploy an oil sensor on Humvees, which we probably wouldn't want someone to hack.
So it's kind of ironic because I sit on a lot of these kinds of panels on IoT, and I have to say that the very first question from the audience is always about security. So thank you for following
making
up
him
on
right.
Security for IoT, and everybody can chime in, is multi-layered. It has to be, right? You have to do it at multiple layers. You have to secure the endpoint, right? It has to be so that it's hard to hack into. Nothing is hack-proof, right? That has to be looked at the endpoint. The connectivity layer has to be highly secure. We do that through, our level of authentication and encryption that we have in cellular networks today. But there's other things that you have to do to make sure that that connection cannot be accessed from the outside. And there's best practices that we have put together in IoT security best practice guidelines that are available. I'm sure other people have them as well. So that connectivity layer has to be the application layer, though. The end-to-end transfer of data needs to be secured in a manner. And the end customer needs to be a part of what that end-to-end security should look like. And then above it all, looking at kind of a threat detection level. If you can do all those levels, then you've got a pretty secure capability, but you always need to be looking at it. So that's kind of my read on where we are today, and it's different based upon the vertical. Some of them have taken this to the extreme where, for example, in automotive, they've created a whole forum where all the automotive manufacturers and their partners get together and work on cybersecurity together, share threat information, things like that. Other industries may consider doing something similar as well.
I'd like to add to that too, that security it's a big deal. It's very important to all of IoT. It's everywhere, right? It comes up in all the conversations, it's everywhere. So definitely needs to be a solution to it. But security also needs to be looked at from the standpoint of what's required for the particular application. In some applications, the amount of security required is very power intensive. You need a big processor to process the security that's involved. And maybe that's got an effect on the battery life, and maybe it's not needed in that situation, as much security. Right? So there's no one answer that fits all. It's just like the previous answer we had about, is there one technology that's going to dominate IoT? No, probably not. Is the same level of security required for everything? No, probably not. But security is important. It's got to be addressed. It's got to be an end-to-end solution that's got to be there.
Sure.
Yeah, and we did talk a little bit earlier about the importance of security by use case, and I think that's why people are really honing in on here. And that is one of the things that especially, I'm excited about being at, with the large carriers, because we do this every day. We protect data, we protect people, we protect information. Nothing's completely hackable or non-hackable, but we get pretty darn close, as close as you can get. And what's great about what we're trying to accomplish now is weaving in those core technologies into everything IoT. So this is why we believe in managing the activities at that network level, as opposed to trying to do things at too much at a surface level. To me, I always call it, the hackers are kind of out your front door versus at the edge of the city. And that's really the way, we try and look at things. Putting everything down into the core components that are as protected as possible, and then layering those same technologies all the way through the stack, is the way we think about things in every one of our industries here.
Yeah, we've got a great white paper online that talks about security. I think we would all agree that at our level, security is in a good place. The endpoint's the weak link. Just ask Chrysler. I mean, you look at the vast majority of failures in the IoT space, that's where it is. I think the carriers and anybody that has a significant wireless backbone has done an extraordinary job of protecting those networks. And I think we have to get a lot more education out at the tail end of this thing so people do a better job.
Yeah, and we as a silicon provider, we do a lot of things mainly based on the technology we needed for cell phones. We're driving that into the IoT space where we can actually authenticate a device to the actual silicon. So you can ensure end-to-end authentication. We also have secure execution environment. We have secure boot. There's a lot of things we do to make sure that if someone happens to get through the front door, they can't then repurpose the device or do something with the device without the device knowing it's been compromised. So it's always in the background. You don't want to run around and say how much you're focused on security because you become a target for hackers. But we certainly, it's in the forefront of everything we do at the chip level. We actually have teams inside our chip division and our corporate engineering division that are constantly trying to hack our own code. So, and sometimes we have people from outside they help us out too. But in all those cases, it is always, in everything we do, everything we commercialize, it's in the forefront.
Very good. Any more questions from the audience? Right here up front and then in the back.
Hi, my name is Dennis Aguilar. I'm with Athonet. We are a software mobile core vendor. We won the GSM Association Award for the best solution for growing smaller and independent networks. My question is, John mentioned that narrowband IoT was going to be a winner. I was surprised to hear that from John. So my question to the carriers is, what do you think the factors that are going to inhibit that growth? And then for Sigfox, and John, which of those factors do you think you could take advantage of to capture more of the market before things come together?
Well, so like most things, I kind of disagree with John. I don't think that there is a clear winner between narrowband IoT and LTE-M. LTE-M actually has a lot going for it. You can reach the same kind of price points. You can reach the same kind of extended coverage. You can reach the same kind of power saving mode. And beyond that, you have full mobility capability. You have the ability in the future to add voice to it. You have the capability to do firmware updates. So what we have found in the IoT industry is that when a customer purchases a certain technology or capability, that what they first thought that they were going to use it for expands over time. I'm not taking away anything from narrowband IoT or actually the other technologies, but if you're a company that thinks you're going to do more, maybe you need to do firmware updates to solve a security hole that somebody found in something. Then you ought to have a technology that can go high enough in bandwidth to do that kind of thing. And so that's one of the reasons why LTE-M, we think, has a lot of legs under it. Now, that's going to vary probably, and different parts of the world are going to pick different standards, perhaps a little bit because of the infrastructure that they already have in the ground. But for us, it's a very clear that LTE-M is going to be able to do a lot of things for us.
I would also add, one of the things that is challenging for customers as they're thinking about developing or moving into an IoT solution is how to get started. And so sometimes what happens is they'll look at one particular problem and say, okay, you know what, I can absorb this, so I'm just going to focus on it. And one of the things that we are working with customers quite a bit, always encouraging them to do, is to think big and then start small and figure out how to scale from there. And that think big, start small, scale methodology kind of forces you to think through on the front end, what do you ultimately want to do? Do you have global considerations in your business or in your community? What kind of security is required, the sensitivity of the data, the information? What kind of interconnections of data do I want to be able to do between this solution, but 2 years from now I may have 5 others and I want to be able to share information. So laying out that overall architecture up front and thinking through it is really important before you pick which technology you're going to end up going with. Then you can start small and do one, test it out, make sure it works, and continue to scale and grow, because as you do that, you know that everything's going to fit together. I'm not a technologist, unlike probably most of the people on the stage here. I'm a business person, so I think in terms of like Lego blocks. If you know that your Lego blocks are all going to have the same size brick and you're going to have the same size circles, and you're interlocked with a certain set of capabilities that are going to be important for you as you scale, you can start off with just a tower of blue bricks. But when you're ready to put in the white and the green and the orange, you know it's going to fit, and you know you're going to have the same reliability with the data and the flow of information as you continue to grow.
Yeah, and from a Sigfox point of view, we see ourselves as focused on a low cost, very low data rate, low power niche. That's where we're at. We're not trying to be everything to everybody. We're not trying to do high data rate. We're not trying to do video. We're not trying to do software downloads. We're trying to be there. And that's where we see our opportunity. We have unlicensed spectrum, lower cost. We're not trying to be servicing all your iPads and iPhones that are out there. We're doing just that niche. And we think that offers us our opportunity.
Yeah, it's funny. I praise narrowband IoT, and Cameron still isn't happy. I just don't know. But
Love you,
you know,
John.
yeah, we've got. Bottom line is we have networks running all over the world today. Our competition to win every one of those networks was cellular, and they chose RPMA. RPMA has significant value that cellular can't bring to the table in many, many use cases, and it's a proven technology. It may only be 8 years old, but that makes it older than LTE. And anything that's coming with LTE, and it's working bulletproof all over the world today, every day. So there is significant value to alternative technologies that are there and that are working very well.
8 years, you must be ready to sunset now.
I just want to.
I love this panel.
Wow. No, I'm actually willing to put in writing in a contract that we won't.
So I don't want to gang up on John, but
Let's go for it.
Let's go for it. So no, actually, I do agree with him on the one hand that narrowband IoT is going to be a very broadly accepted, widely deployed, high volume technology, but not at the expense of LTE-M. These things are going to coexist in the same networks because they serve different use cases. Cameron referred to mobility. There are cases where, depending on your payload, your message size, you're actually going to get better battery life on the faster technology than on the slower one. So you'd be better off if you're in a wristband or a healthcare device choosing M1 over narrowband IoT because the battery will last longer for certain use cases. So these technologies don't obsolete one after the other. They coexist on, and importantly, on the same network. This is not, he's playing up this whole, oh, you got M, you got 0, you got 1, you got NB. They don't replace each other. They don't obsolete each other. They complement each other because they serve different use cases.
Complement or complicate? I mean, it's like how many things do you have to choose from? How many flavors of vanilla do you need to
Do you
be
deny
successful?
that? Do you deny that there are multiple use cases in the IoT?
Oh, no, there are many, many
Exactly.
multiple
They
use
need
cases,
different
so
solutions.
My point exactly.
And we have multiple different solutions. You have one different solution.
That covers 86% of the market if you look at the research out there. ABI just put out a report last week if you want to go to their website and check them out. I mean, if we would have put the report out, no one would have believed it because it's a little too favorable to us. But it's a great report if you want to go download that and look at it. And it basically talks about the two winners in the end, they believe, will be NB-IoT and RPMA. So we're happy to see what they've come up with, the conclusions that they have. But there's room for a lot of success here. And I look forward to many more years with Cameron on the panel.
Can't wait to hear their next report also, who the winners are in the next report.
Great.
We have just a few more minutes left. I had one question in the back.
Hi, can you talk about impact on network operations given the billions projected in 2020 and beyond? How does that impact network operations centers and service provider space? What skill sets, systems are they in place now? Can you scale? Capital investment associated with that, et cetera?
I'll take a stab at that one. Kind of what we were talking about before with the full end-to-end capabilities that are needed to truly support the rollout of an IoT solution. I think the operations aspects of it is incredibly important. And I think a lot of convergence on different operations activities. So, for example, again, in my world in the city area, the types of data that used to be really kept in individual silos, maybe the police department has one type of information, not really shared with the fire department, not really shared with the hospitals or other types of groups, because everyone has their own architectures, their own infrastructure, et cetera. In the future, I see a lot of this coming together, and that's what they're working on, right? I mean, they really are trying to be able to look at the interconnectivity and how can you benefit the citizens in my industry, by sharing that information across those towers. And on the operations side, it really kind of comes together there. Being able to ensure that there are appropriate firewalls as necessary, but then when you do need to be able to share data, you can. And from an operations perspective, you can start managing things together. So all of a sudden, security and maintenance and other types of activities could be kind of managed in a similar process. So training is different. The way you actually look at the management capabilities is different. So it's not just a traditional NOC really anymore, that you can start thinking about the partnerships between what a traditional operations center might look like versus what an operations center of the future might look like. And I think we're just starting to touch on those capabilities.
I think the other aspect of this is as we move into the future, a lot of this comes together, even for IoT, when we talk about the software-defined network. We haven't talked about the core network at all up here, really. We've been talking about the radio and device side. But when you have a software-defined network to work with, now you can, adding capacity becomes a whole different way of doing things. You have general purpose computing, you have software over the top of it, and adding capacity is adding more memory, right? Or actually allowing that memory to be used for certain functions. It's becoming easier and easier from an operations perspective to operate our networks, and you can talk in the future about network slicing, where you take portions of the software-defined network, you cordon it off for particular use cases, and they can't be at all interfered with in any other way by other ones. So you can talk about one for each different vertical, for example. So there's a lot going on in the operations space as we move into software-defined network that's really going to help IoT.
Fantastic. Might be able to squeeze one more in. Anybody have a quick one? He beat you back there in the back in the dark jacket. Oh. Coming at you.
Hi, my name is Adnan from Inritsu. Thank you very much for hosting this session. Real quickly, I think you answered the first part of the topic, which is which ones will live. We're yet to answer which ones will die from a technology perspective. But on a lighter note, I had a question since the panel is over here. There's been a lot of forecasts with the number of devices on the IoT network in 2025, about 25 billion to 50 billion. But what I have been reading is maybe it's a big apple pie, but possibly the cellular piece is going to be 10 to 15%. Is that something what the lady and gentleman have heard from a cellular perspective? Is that 10 to 15% enough return on investment for us right now versus the remaining 90 to 85% being on the non-cellular networks like Zigbee, Sigfox, LoRa, Wi-Fi, so on and so forth? Thank you.
Go ahead.
Is that to the carriers again? Yeah, when you're talking in terms of billions and then you talk a percent of billions, that's a heck of a lot. So we're adding over 1 million IoT subscribers a quarter around AT&T. This is truly a growth engine for the world. And I think whether it's cellular, whether it's the unlicensed technologies we're talking about up here, the very short range, Bluetooth and Zigbee and everything, yeah, all of those are going to add in, but there's going to be a massive chunk that is cellular-based that is going to be out there, and it does make sense to invest in it.
And the other thing I would just add to that is we are such on that early phase of the IoT activities. And what's really great about this space is a lot of the new innovation, the startups, the smaller companies that are coming in are coming up with the technologies that are continually challenging all of us and helping us move along. I think, though, when you start seeing the massive scale, again, and when you start thinking about things that are requiring the level of protection and security and maybe global capabilities or other types of things that are required, you'll start seeing more and more use of the technologies that we've been talking about over here. And you really are just seeing some of those bigger scale activities happen. So although the percentages may look a little different right now, I think it's also an indication of where we are as an industry of, kind of individual point solutions, testing things out in pilots and in small projects versus the large global scale activities that will, I think, really change things.
There might be one thing we can agree on. Cellular is going to get more than 15%. We all know that.
And on that warm and fuzzy note, we will end things. I'd like to thank our sponsors, Ingenu, Qualcomm, and Sequans, and our partner 5G Americas. Sorry, 5G Americas, I didn't mention in the opening remarks.